concept of using an autotransformer to explain a separately derived system was first published in Electrical World on June 21, 1924. The author of this publication was F.A. Annett. To understand the significance of this, let's delve into autotransformers and separately derived systems individually before connecting the two. An autotransformer is a type of transformer that uses only one winding to act as both the primary and secondary windings. Unlike a traditional transformer that uses two or more electrically isolated windings, an autotransformer achieves voltage transformation by tapping the single winding at different points. The portion of the winding shared by both the primary and secondary circuits carries a current that is proportional to the voltage difference between the input and output. This design offers several advantages, including smaller size, lighter weight, and low cost compared to two-winding transformers of the same rating. However, it's crucial to remember that the primary and secondary circuits are not electrically isolated in an autotransformer. This lack of isolation can be a safety concern in certain applications. Autotransformers are commonly used in applications where a small voltage boost or reduction is needed, such as adjusting voltage levels for sensitive equipment or starting large motors. They are also employed in power transmission systems for voltage regulation and in railway electrification. Now let's define what a separately derived system is. A separately derived system is an electrical power source, such as a generator, transformer, or converter, that is not electrically connected to the main power source of a building or facility. This means that the separately derived system has its own neutral conductor that is isolated from the main system's neutral. The purpose of a separately derived system is to provide a dedicated power source for specific loads or areas, isolating them from voltage fluctuations, harmonics, or other electrical disturbances that may be present in the main power system. Separately derived systems are often used in critical applications where a clean and reliable power supply is essential, such as hospitals, data centers, and industrial control systems. The National Electrical Code, or NEC, defines the requirements for separately derived systems in Article 250.30. This section outlines the grounding and bonding requirements to ensure the safety and proper operation of these systems. The NEC mandates that a separately derived system must be grounded at the source, typically by connecting the neutral conductor to a grounding electrode. This grounding connection provides a path for fault current to flow back to the source, allowing overcurrent protection devices to operate and clear the fault. The bonding requirements ensure that all non-current carrying metal parts of the separately derived system, such as enclosures and raceways, are electrically connected to the grounding system. This bonding prevents voltage differences from developing between these metal parts, reducing the risk of electric shock. The NEC also specifies the requirements for overcurrent protection of separately derived systems. Overcurrent protection devices, such as circuit breakers or fuses, must be installed to protect the conductors and equipment from overload and short-circuit conditions. The size and type of overcurrent protection devices must be selected based on the ampacity of the conductors and the characteristics of the loads being served. In the context of electrical systems, understanding how autotransformers can be used to explain separately derived systems is crucial for grasping the nuances of power distribution and safety. The 1924 Electrical World publication by F.A. Annett likely provided insights into how autotransformers can be conceptually linked to separately derived systems, aiding in the understanding and design of these systems. While a direct electrical connection might not always exist in a practical separately derived system setup, the autotransformer analogy can clarify the voltage transformation and isolation principles involved. The significance of F.A. Annett's contribution lies in the historical context of electrical engineering. The early 20th century was a period of rapid development and innovation in electrical technology. As power systems became more complex, engineers needed clear and concise explanations of new concepts and technologies. Annett's publication in Electrical World provided a valuable resource for engineers and technicians who were working with separately derived systems. The use of an autotransformer analogy likely helped to simplify the understanding of these systems, making them more accessible to a wider audience. The article may have described how an autotransformer, with its single winding and tapped connections, could be conceptually used to create a separately derived system. By tapping the winding at different points, different voltage levels could be obtained, effectively creating a new power source that is isolated from the main supply. The article probably detailed the grounding and bonding requirements for such a system, emphasizing the importance of safety and proper operation. It's worth noting that while an autotransformer can be used to explain the concept of a separately derived system, it's not a direct replacement for a true separately derived system in all applications. A true separately derived system, such as a transformer with isolated windings, provides a higher degree of isolation and protection than an autotransformer. This is especially important in critical applications where a clean and reliable power supply is essential. To further clarify the concept, consider a scenario where a building has a main power source and a backup generator. The backup generator is a separately derived system because it is not electrically connected to the main power source. When the main power fails, the generator starts up and provides power to essential loads such as emergency lighting and life support equipment. The generator has its own neutral conductor that is isolated from the main system's neutral. This isolation prevents any electrical disturbances from the main system from affecting the generator power loads. The NEC requires that the generator be grounded at the source, typically by connecting the neutral conductor to a grounding electrode. This grounding connection provides a path for fault current to flow back to the generator, allowing overcurrent protection devices to operate and clear the fault. The generator's enclosure and other non-current carrying metal parts must also be bonded to the grounding system to prevent voltage differences from developing. Understanding the historical context of electrical engineering is essential for appreciating the contributions of early pioneers like F.A. Annett. His work in electrical world helped to shape the understanding and application of separately derived systems. The concept of using an autotransformer to explain these systems remains a valuable tool for electrical engineers and technicians. In conclusion, the autotransformer explanation of separately derived systems first appeared in Electrical World on June 21, 1924, authored by F.A. Annett. This publication provided a valuable contribution to the understanding and application of these systems in electrical engineering.